Hey everyone, we're going to talk about decomposing a function. In the previous lesson, we talked about composing a function, take two functions and combine them together. And now what we're going to do is we're going to look at that composition of function and see if we can break it apart. There's not just one answer whenever you decompose a function. You're going to have a variety of answers. Okay? But what we look for is the most obvious one. How your book illustrates the notation for a composition of functions. I showed you that, but what they'll call it in most of your problems is just h of x, and that's all that it is. We compose together two functions to make another function. So we have this function, and it is a composite of two functions. We want to see if we can break it down. So h of x is the composition of functions of f and g, or the function f of g of x. And here we have an example. So you're given h of x, and it is listed as x squared minus 4x plus 3, all of that to the third power. And we want to be able to look at breaking this down. Well, if we think of our function as this, is that we have f of g of x. What I'm looking at is how can I break this down? What inside of here can just be said, okay, this is g of x, because that's the simplest way to view it. And then what's being done to all of this that I can then say, well, that's f of x. And this one here, it should be obvious, hopefully, especially after we explain it, is that if I just view all of this as being the x in f of x, what I'm saying is f of x could simply be x to the third. And remember, whenever I make my composition of functions, I replace the value of x with whatever g of x is. So for this function, if I view this whole thing as saying, okay, well, I'll just say that's x to the third, well, that's my f of x. Therefore, what's inside of here in lieu of x is g of x squared minus 4x plus 3. And you always verify after you do your decomposition. You always check your work for anything. But if I look at this and say, okay, so I have the equation f of x, and I'm going to put g of x in place of x. So I take g of x, put it in there in place of x. Yes, this is a solution for my decomposition of functions. It is the most obvious decomposition, but there can be others. And those get more complex to where you have to look and say, okay, well, if I add this by 2, or if I need to make this function be minus 7 and this one be plus 2 so I can get a negative 5. And some of them can be very tedious to do. So look for the most common or the most obvious decomposition. All right, another example. Go ahead and pause the video and see if you can figure out the decomposition of functions. Okay, so what I know is that this right here is simply the function f of g of x. So what I need to be able to do is look at and say, what is f of x just by itself? If I could pull out g of x, what could I have g of x be? And if I look at this and I can say, okay, well, how about I just make f of x be x minus 1 over x plus 3, or plus 1. And then I say g of x is x cubed. Because again, for my structure, what I'm saying is I'm going to take the function f of x, and in place of the x's in that function, I'm going to put in g of x. If I plug in g of x saying that it's x cubed, my x's turn into x cubed. And to verify, f of g of x, and I'll rewrite it. This is my value for f of x, and this is my value for g of x. I know that I'm going to take f of x, viewing it like this, and I'm replacing my x value with g of x, I'm going to replace each x value with g of x. So I have x cubed minus 1 over x cubed plus 1. And yes, it is correct. Okay guys, continue to watch the videos from the publisher. Structure and critically think about your homework problems, working them the same way each time. Good luck on the remaining homework problems.